Okay. Hello guys, good evening. So today I'll get you through this few questions of time value of money, where we try to apply the concept of time value of money, right? So these are important. So let's try to go through it. So you're given with the scenario here. It assumes that your father is now 50. So it is always advisable for you to draw a timeline whenever possible when doing this kind of questions, right? So let's try to draw a timeline, and these would be pretty handy for you to understand what the question is trying to say and what you should be looking forward to do. So assume that your father is now 50. So this timeline represents the age of your father, right? So now he is 50. So today, this is 50 years old. He plans to retire in 10 years from now. So if he's 50 today, if he retires 10 years from now, that's going to be 60 years old. That means he's going to retire from the age of 60 and expect to leave for 25 years after he retires. So if the retirement age is 60, if you add up 25 to it, that means he will be getting those retirement funds until the age of 85. And the question itself is pretty much clear in terms of like under what age he expect to receive those uh, retirement payments, right? So, and again, moving forward, he wants the first retirement payment to have the same purchasing power. Mind it, the purchasing power at the time he retires as 40,000 has today. So basically, what he wants to have is whatever that 40,000 today can buy, he wants to have that exact amount of money to receive once he starts his retirement plan. He wants all of his subsequent retirement payment to be equal to his first payment. That means, like whatever amount this uh, equals to after consider for, like the time value of money, the portion adjusting for purchasing power, that's definitely inflation. Whatever that he is supposed to receive at the beginning of the 60th year, he wants to receive the same amount of money henceforward. So that means whatever amount that he's going to receive as a payment, as a pension payment, it is going to remain the same across the year 25 years period of time, right? So question further states that that extra clarification is given to you. Do not let the retirement payments grow with inflation. That means it is not going to grow from here onwards here. That means whatever amount that is going to receive is going to be the same across these 25 years of time. Your father realizes that if the inflation occurs, the real value of his retirement income will decline year by year after he retires. That it definitely is talking about, like trying to maintain the same purchasing power. That means he is realizing, or at least he knows, that the value of money is going to change across the time in terms of its purchasing power as well. Moving forward, his retirement income will begin the day he retires. So that basically means that if he's going to retire from the age of 60, that he would like to receive the payment right at front, right? So at the beginning of the 60th year, he'd like to have the payment. So that means he retires 10 years from today, and he will then receive 24 additional annual payments. That means if he receives the first installment here, and then he expect to receive the, like for the next 25 years, that means first installment here, followed by the 24 more installments, right? 20 plus 24 more payments. So basically, the way the question is putting it forward, we can like make out of it that this annuity that is going to be present, like from 60th year to 85 year, it is going to be made at the beginning of the period. So if you are making the annuities at the beginning of the period, then we definitely can tell that is an annuity due, right? So you may want to recall that what the annuity due is, like just to give you the brief idea, that annuity due is the amount of the fixed payment received at the beginning of each year, right? That's the kind of annuity what we call the annuity due. So moving forward, inflation is expected to be 5 years, so we are given with the inflation rate. So inflation rate is basically 5 years. That means what if this 40,000 is today, we need to account for 5% of annual inflation adjustments for us to decide what's going to be the retirement payment 60th year forward. Okay, he currently has 100,000 saved, so that means like besides the amount that he needs to deposit over this 10 years, he has this 100,000 at the beginning and expect to earn a return on his savings of 8% per year. So basically the applicable interest rate, let us denote it with I, is going to be 8%. To the nearest dollar, how much must he save during each of the next 10 years? So basically question is asking you like what would be the annual payment to be made at the end of each year. And like as you can see, the question states that with equal deposit being made at the end of each year. So basically it's trying to see that how much of a payment that you have to make at the end of each year for the next 10 year to make this retirement plan happen, right? So if you notice that after the 60th year it is annuity due, but from the 50th year to the 60th year it is of nature of ordinary annuity. You might want to refresh again that what the ordinary annuity is. Just to give you the brief idea, ordinary annuity is the fixed payment made at the interval of each period towards the end of the period, at the end of each period, like emphasize this is annuity due is at the beginning of the period, right? And ordinary annuity is at the end of the period. That's the basic difference. So now we need to find out how much needs to deposit it. So first of all, like you need to create a mind map that how you're going to proceed with the question. So first of all, that his idea is that today is 40,000 equivalent of amount that whatever this can purchase, he wants to get from hence onward towards here. So if we need to find out how much that 40,000 turns out to be 10 years from now after considering for inflation, that we can find out, like the equivalent payment, let's call it, instead of equivalent amount, let's call it like equivalent annuity considering 5% inflation. Alright, so basically what we're trying to do is we're trying to find what this 40,000 looks like after considering for this inflation rate at the end of 10th year, right? So basically that's just trying to finding out the future value of that 40,000 10 years from now. So that's going to be 40,000 times 1 plus 0.05 to the power 10. Okay, so let's try to calculate. Alright, so 40,000 times 1.05 to the power 10. So this is 65,155.78. Alright, so basically what you need to understand is this guy, once he retires, wants to get every year after 60th year 65,155.78. So how many numbers of the 65,155.78 that this person wants? Alright, so one this payment starting at 60th year plus 24 such payments, right? 24 such installments. Alright. So since we are like interested to find out like how much you have to deposit over here, so it would be great if you can find out like what would be the sum of these, like some of these installments at the end of, or probably at the beginning of 60th year. So that's very interesting to find out. So basically, if you if you stand over here and if you try to find out what is the amount of these payment on this point of time, basically you need to find out the present value, right? Present value of these installment on today's date. So let's try to find out the present value. So present value of retirement payment at year 60, right? So basically you're trying to find out what is the cumulative amount of those installments at the end of 60th year, right? So that you can find out as 65,155.78. We know how to find out the uh, present value. Let's see, 1 divided by, let us suppose the interest rate is 8% as given. 1 minus 1 divided by 1.08 to the power 25. And since we are working with annuity due, we know that we have to adjust this formula like this towards the end, right? So this is basically, like adjusting the discounting effect at least by one period, like because you're getting the payment towards the beginning of the year. So to the power 25, let's calculate 0.08 times 1.08 times 65,155.78. Right. So if I see my calculation that shows, it turns around to be 751,165.23. Alright, so what does it mean basically? Okay, so that basically means you're gonna have to, if you add all this amount of 65,155.78, considering the 8% interest, that means the sum of money on this point of time, that is at the end of 60th year, is equal to 751,165. So that means if you have this amount of money accumulated by this period of time, afterwards every year if you withdraw this 65,155.78, then you can withdraw 25 installment as such, starting at the beginning of each year. Again, but we're not interested with this figure. We need to find out that how much you need to deposit every year 10 years forward to get to this amount, right? So the idea is you need to reach here, right? That is basically you need to accumulate 751,165.23 until this period of time. The idea is how much you need to save across these period, right? And one thing that you have to understand is you don't need to save the entire amount of money, because at front, at the beginning of the time, you already have this amount of money, 100,000. So you can adjust that amount of money, like because this 100,000 is also going to earn you some amount of interest. So let's see like how much 100,000 earns. Like here, 100,000, the amount of the interest that is earns over the 10-year period of time, and 100,000, that amount of money you did not deposit. You need not be depositing that amount of money. So let's try to find out that the future value. Okay, future value of initial sum of 100,000, right? So basically that 100,000, if you invest it at the rate of 8% for the 10 years, is going to be 100,000.08 to the power 10 is going to 215,892.49. So basically the idea is this 100,000, let me write it over here with a different color. So this 100,000 which you have towards the beginning of the year, if you consider with the 8% interest rate, that turns out to be 215,892 towards the end of the year 10. The idea is you need to have this amount of money. You already have this amount of money, so how much money you need to save is the difference between that, right? So you can find out amount amount to be saved towards amount to be saved equals to 751,165.23 minus 215,892.49. All right, so this is 751 165.23. That turns around to be 100. All right, let me again calculate it. 751 165 751,165.23 minus 215,892.49. All right, so this is going to be 535,272.74. Okay, so let's draw another timeline to be much more clear about it. So let's copy everything that we have. 50 years, that's on the 60 year, and then the 85 years. So as of now, like we have already, done the calculation of this part, like how much money that needs to be accumulated over this 25-year period, like towards this end. You have to have, as the question said, 165.23. Now you already have this amount of money, with the amount of saving that you made initially, 215,892.49, and the difference is 535,272.74. So basically the idea is you need to save every year, like for the 10 years onward. At the end of every year, you need to save a certain amount of money, that's PMT, as such that that amount accumulates to this amount of money. So what is that payment? What is that payment to be made at the end of every year, right? So that's amount that we need to find out, right? So let's try to find out what is that amount. So we know that if we try to accumulate this payment over the year, like this is kind of a future value, this is your payment, and if it accumulates at the end of every year, it's a kind of ordinary annuity. You just need to find out the future value of the ordinary annuity that we very well know how to calculate. The future value of ordinary annuity is the PMT times 1 plus I to the power n minus 1 divided by I, right? Let's try to fill in the amount. 535,272.74 equals to PMT times 1 plus I, the interest rate. We consider it doesn't change over the 10 years period of time, minus 1 divided by the interest rate 0.08. Always remember that the interests are represented in fractions, right? That's be something basic. All right, so let's try to solve this thing. And then PMT, the amount that you need to deposit towards the end of every year for you to get your desired retirement plan, is 535 to 72.74 times 0.08 divided by 1.08 to the power 10 minus 1. So that turns around to be 36,949.603. All right, so we got it. Right, so this is the amount that you need to deposit every year for you to be able to get your retirement payment of rupees 65,155.78, which is equivalent to rupees 40,000 considering the purchasing power with the adjustment factor of 5% every year. Like once you get that amount, this amount for 10 years, you'll be able to get this amount for the next 25 years at the beginning of each year. It's a very simple question. Just you need, there are two concepts that's being used. The one concept is, where should I write? Okay, one concept is, like how you account for annuity due. Another one is for the ordinary annuity. And needless to say, if you are able to understand how to work out the present values and the future values of these annuities, you will be able to solve this question. So hope you understand it. If not,